Please start your recordings. Rick, please record to the cloud.
Okay, just a second here. Oops. To the cloud. And just have to get my live stream sound hooked up here. Okay, there we go. Get the microphone going. Okay. Welcome everyone to the Tuesday, November 3rd afternoon session at the Keshe Foundation Spaceship Institute. We're doing a live public broadcasting with questions and answers on the primarily on the energy systems that have been introduced recently by the Keshe Foundation and Mr. Keshe, and what we call the MagGrav's power system. And this is part of the blueprint teaching, but this will be just with the Shandor will start off the teaching today, and it'll be primarily with the knowledge seekers of that have been involved with this. Okay, I think that's about it. Are you ready to go?
Yes, I am. Sorry for unshade face. I was very busy in the past days. Almost day and night working, but I try to show not much of my unshade face, but more about explanations and more about showing, demonstrating how to do.
Oh yeah, hang on a second. I'm not getting my audio. I think I know what the problem is.
So we have an
okay, there we go. Sorry, I didn't have your audio. Now we're okay. Go ahead.
Okay, so so many people asked so many questions, for instance, about interpreting what does it mean clockwise or anti-clockwise, because if you look at the same thing from different viewpoints, you can interpret it in a different way. So we would like to clarify that. So what does it mean? And also how to make the coils, what materials are needed, such as like copper wire, and we will need some basic chemicals like caustic soda or sodium hydroxide or simply caustic, or probably you will need some salt, some sea salt, which will be needed for creating gas materials. We will need a bunch of other kind of various metals to make combined gases. So we have here a piece of brass, so we have a bit of iron, we have their hard drive disk, which is according to color it's covered by molybdenum, and of course we need a nano-coated materials like plates, coils, etc. And probably we will need a lot of distilled water for making the gas and for washing the nano-coated materials from caustic. And also some tools will be needed. So most of tools don't need special investment, but or if they need, if you don't have them, you can use them later to other works. One of these very useful tools, it will be a gas burner. There are different models, some are with piezo spark starter, or you can put it with this extension on a flat surface to have it upwards to work above. So this will be needed to soften the ends of the coils to be able to twist them one on the top of the other. And it will be needed for some measuring tool for length. Optional to have a caliper for checking the copper wire which you buy, or for diameter the other. parts which you use for making the coils. For making the coils, you will need a pair of rods or tubes of different diameters, one for the thinner inner coil and the other for the outer coil. So I don't go in details about the construction of the blueprint because that was published, presented during 1 week. Rather, I'd focus on some special little things which were not presented there. For instance, you need to cut your metal plates to be able to produce your Gans. So this is a zinc plate, for instance. I used to cut it in 2 sides and to make the hooks which will be used to hang them on the top of the plastic container without the need of other clamps. So with just such a clips, you can already make the connection parts, no need for drilling so much. And probably there will be need, when you will have the coils, you will need 3 hard plastic plates, which will be the support for the coils. You will need some drills to drill some holes around, and you will need such a Ziploc tires to fix them through the holes to make the construction to be solid. You will need 3 ping pong balls or rather small globes of plastic or metal which you nano coat, and then you will put Gans paste in them. In the middle as like a central sun to provide the plasmatic energy for the coils. And of course you will need various plastic containers, bigger, smaller, for making the nano coating process. So this kind of plastic box, for instance, just normal polypropylene boxes. And also you can use for Gans production some repurposed things like food bucket. This is producing now CO2 Gans here. So it has a nano-coated copper coil and it has a zinc plate here on the other side. And on the bottom already you see some CO2 Gans. You need other Ganses as well. As I said, for making other Ganses, it's good to have such a higher order materials on the table of elements. For instance, if you can dismember such a hard drives, the older ones were plated with platinum. The newer ones, which you see more brownish, yellowish, like the sunglasses color on it, these are covered with molybdenum. So, and we have got an idea from one of the knowledge seekers to use such a cut bottle, which has such a sport tip with a valve. So in case you will have here the Gans produced, it will be very open, very easy just to pull this end and to release the content with the liquid just from the bottom. Just an idea. So otherwise you will need some syringe to extract the Gans from the containers or buckets. So let's see, the most interesting parts are which wires we use. And you have to know that every maker has different diameter of wires. For instance, I have bought that so-called MCU 2.5 square millimeter wire, which is a standard in Europe. We have here 1.5 square millimeters cross section, not diameter, cross section, or 2.5. This theoretically, according to the rules of the geometry, should have 1.78 millimeters thickness. Just let's see with a caliper how much is in fact. This is actually 1.7 only. So it's right to be used instead of the 14 gauge American wire gauge 14 wire, which should be 1.6 millimeters. So actually it's 0.8 millimeters less than it is according to its specification, which is not a problem because we don't need too heavy wires. Another interesting point, you will need cable, flexible cable with plugs at the ends, and on the other part with such a socket to connect your system, and you connect your power devices to the system. And what's interesting that the cross section of it shall be equal to the cross section of the wires which you use. If you use a thinner cross section, like I bought one and I found it's not good because it's too thin, in that case you will create a bottleneck for the energy flow, and part of the energy will not go through the wire where it's supposed to go, but it will be reflected back and will produce the heating up of the unit. So whenever you have such technical issues like heating up or other things, so please put your questions, we will try to answer them. So I bought insulated wire, which I stripped it very easily with a potato peeler. It was very easy to cut away and to pull away the external wire. I arranged it in a way that if I put it on the floor, this can come up winding after winding very freely to be able to twist it very easily. So I put this on the floor. Okay, put this clips away. And here's a very useful tool. It's an electric screwdriver or drill with battery. It's a portable one. This will be very helpful for making the coils. So now about the direction of winding, I made a drawing here. What does it mean, clockwise or counterclockwise? So we look at the start point, which is nearest to us, and to the direction of the flow of the coil, the direction of going the wire, like going away from us. So in this case, if you have it like on the top, you have a counterclockwise. So the turns go in opposite direction to the clock, and at the bottom you have the clockwise version. So this created a lot of confusion because different people look at the coil from different ends, and they consider differently the same thing as being either clockwise or counterclockwise. Please note, all the coils in the system have to be winded counterclockwise, and also when you twist the wires, you also have to use a counterclockwise twist. So let's put the camera here. I want to show here. Here I have improvised working bench from some repurposed boards, so it was no problem to drill holes in it. Please don't drill your tables at home. Better get a winch on the table and put a piece of heavy board or plywood in and use that for this purpose. So first of all, I have here holes which are with purpose to hold the wire. So I'm putting the wire through. Okay, here is the end. I hope you can see it. Okay. When we start making a coil, I recommend to use about 25 centimeters or 10 inches free end. So it's about 25 centimeters or 10 inches. Doesn't have to be accurate because later we will trim the wires when we connect together the coils. So this hole will lead the wire, and the wire lies under the desk in a coil in such a way that it can freely released. So now the next tools which are needed, once we have here a pipe for the bigger diameter coil, and we have this for the smaller diameter coil. So for the smaller diameter, it's a bit tricky how to hold the end of the wire. So I'm fixing it into the chuck. I fix the rod into the chuck. Okay, it's fixed. And here we have some free space between the close of the chuck. So I took some steel wire from a coat hanger. You know those coat hangers which are given from the dry cleaners when you clean your suit. just cut a piece of that and with some pliers just bend it in a way and shape to fit easily here in between these openings between the close of the chuck. This is needed only for the thin coil. For the thicker one, you will not need that because anyway the chuck will be filled with this 10 millimeters rod. Here I have a 4 millimeters rod. So now I place the end of the rod through the hole. It's a 5 millimeters hole, but it could be 4 or 4.5 millimeters. So it moves easily here in and out. How to make it to position? I'm trying to reposition to let you see more. Okay. And now, okay, I put here this little hook, this U shape, and I try to fix it into the chuck. So it went in. So this was a bit tricky to figure it out. And now we have to press this wire very tightly against the board. So it will be not good to use the thumb. You can use a piece of plastic or piece of wood. I'm using this lighter. So I make one turn only at the beginning. Always the machine turns clockwise, on right, not on left. And we have made a first turn. Then I have here the excess of wire. It's about 25 centimeters. So it will not be good to let it spin around because it will poke my eyes. So I'll put it here. I will turn it here in such a way while it turns to never go with the sharp end into the front. You see, it goes in that direction, so it will not poke my fingers. And now, when we start turning it, we keep pressing here to keep the wire well extended. And also, we have to push the drill towards the board. So never pull, just keep it pressed as tightly as possible. One of the ways to count is to put here a mark. And you can go slowly and count. Here I have already 1, 2, 3 windings, so I can count 4, 5, 6, 7, 8, 9. So this is one of the ways to count. Or once you count it, you can put here a ruler or something, a spacer, and to make a mark exactly at the place where you want to end the coil, where you have the number of turns. I choose another method for the long coils. I already cut the length of the tube or the 4 millimeter rod at the proper length for having 162 windings. So I can work faster. So always keep pushing, pressing. Don't pull the drill. Just push it. So the length finished, and the length is measured according to how many coils I need. Or otherwise, you should put here on this other end, you should put here a centimeter or something with a mark to measure exactly how long you want to go. And to stop when we reach to that mark. So by the way, this coil is 32 centimeters. Okay, so let's put the camera back. So when we reach to the end, we pull out the wire. I release the rod from the chuck. Okay. I put away carefully this precious piece of metal. This will be needed later. I extract the rod. And now, from the other end, I have to leave enough long end as much as needed for making this end to go through the inside of the coil to make a perfect round circle. So I measured here, I found it safety for me and for having enough long connections, a length of 78 centimeters from 78 centimeters for the long coil, and for the shorter coils I will have half of that, 390. So this is 78 exactly. Don't even need the centimeter for that because I already know it by the eye. And we just have to cut it. And we can start with this end, the next coil. So can produce coil after coil easily. Ouch, this is falling off. Okay. Don't like the camera. Okay. So here is again one of the coils. So it has a shorter end and it has a longer end. So this long end, by rule of thumb, should be about 1.5 times longer than the length of the coil. This we shall straighten it. I need polycomb pliers to make on the shorter end to turn it back. When we make the nano coating, this has to be turned back, but you can do that later after planning the assembly of the coils according to your own wish. When you think about how you interconnect the wires, and you can trim this according to the length. Usually for the exit of the coil, I leave only 5 centimeters, and for the entrance of the for the exit, I leave 15 centimeters or 20 centimeters, plus how much is needed to find its place. And for the entry of a larger coil, it's enough only 5 centimeters just to have a way to twist up the end of the other. So now this is the first one, and if you do the nano coating with heat, like Philippine does, in that case you can just heat it up and nano coat it by heat. Otherwise, if you use caustic, the caustic will not go inside the windings, between the windings. So we have to make a spacing. So I measured, I calculated that I'd wish to have the coil, the longer coil of the length of 48 centimeters. So I put here a mark on, my desk at 48 centimeters. As you can see, it is there. That is the small mark. I hold the one end of the coil with my pliers here. I hold that to the mark, and I'm pulling with my hand the other until I reach to the desired length. And this is a hard, tough wire. It's not easy to extend it. So it comes back a few centimeters, so I have to pull it several times to adjust it until it reaches exactly the dimension which I want. Okay. Once more. It's okay. If we pulled accidentally too much, we can still push them together, or to correct if there is need for uniformity. So this is one coil. So now let's see how to make the larger coil. You know, I always take care about the wire because it can mess up sometimes. So if this happened, we have to arrange it again nicely. Just let me put it inside again. Little mess of yours here. I've seen a genuine, very interesting solution when somebody used directly the insulated coil using this technique with the electric screwdriver like I did, but he already fixed with some screws on the back of the board the potato peeler. So in one step he did the peeling and the twisting. So he saved a couple of hours of peeling the wire. Okay. So let's find again the hole. Okay. Again, we leave here an end of about 10 inches or 25 centimeters for the beginning. And now we don't need this thing, this U-shaped wire, because we will insert the end of the wire here into this orifice which I drilled on the pipe. You have to know that drilling a pipe is rather tricky because the tip of the drill will just tend to slip away. So usually use a flat file to file a flat surface, or you put a piece of plaster or duct tape, which will hold the tip of the drill still until you make the hole. So now we use the other hole, the bigger one. So here will be our machine for making it. And let's insert the wire. We set here 25 centimeters to be free. Okay. We push it there. We fix it into the chuck. And after we have the first turn, again, we wind here the excessive wire in a safe way. Let it freely going. And here we hold it very well still. And we keep pushing it. If you make the short coil, just be sure you put the measure near to the coil on the desk, and you have a mark there where you have the point where to finish the coil, to don't make it too long. In this case, we are making again a long one, so I use the entire length of the pipe. Here is the end. Again, we take it out of the chuck. And we measure about 78 centimeters of free end. For the shorter coil, half will be enough. And we cut it. And here it is the bigger coil. It's a nice coil. Now it comes the harder part, because we have to release here this end. So if you can get not a pipe but a solid steel bar, maybe you can make a groove here, a cut all along. In that case, it will be easy to take it out. Otherwise, if you have a pipe which would not support such a thing, you have to use the pliers to push through the beginning. So you see, I am pushing and pushing until I have here a small hole that I can insert the ends of the pliers. So I'm pulling a little by little, carefully to not scratch the wire. And when my index finger fits, I can pull it much comfortably. And this was the hardest part of it, how to take out the wire from the middle. So again, we have to extend this to the. Just a second. you see, this is the length which I have chosen, and this is the length of the very tight coil. So when you use the caustic method, you cannot leave it as tight because the caustic will not enter in between the windings. So that's why we have to extend it to make a free space where the caustic to enter. And we do when we do the second phase, the drying phase of the nano coating, to not keep moist between the windings because of the capillarity. So we need uniform conditions. So if you use just the fire for nano coating, you can leave it in this size, because the fire, the high temperature will create anyway, will force the nano coating in between the windings. But if you use the caustic method, you have to extend it to the same length as the previous, just a little more, and that's it. So I have two coils of the same length. Okay, adjust it a little bit. Now insert the shorter coil, the thinner coil in the thicker coil. This is how they go inside each other. And then we have the long wire from the inner coil, this one, and this, if I'm looking to it, it will show to be clockwise. From your side it looks anti-clockwise, but we push the end through the middle of the thinner coil, so not through the bigger coil, but through the smaller coil, to the thinner one. And this has to be pushed until it comes out from the other side. You can see it's here. So from here on I can just pull, pull, pull. And when I pulled these together, we reach to close the ends. I just bend it a little bit to hold them fixed. And here the shape is not very perfect, so we have to adjust it in our hands to make it to be about the same nice round shape. So this may need a little skill and attention. So here we go. So we have the big coil. Same we do for the smaller coil and the big one and the small one. We pair of two coils, one into the other, will make a set, and you will need 3 sets of that. In total 12 coils. So are there any questions about this one? About the coiling?
How much meters do you need to make the 2 coils or the 6 coils?
Repeat please, I didn't got well.
How much meters do you need of the wires to do the coils?
Good idea. I bought a 100 meters roll of MCU 2.5 square millimeters, and I extended them according, but the extension doesn't change the length. And I used the 10 millimeter pipe and the 4 millimeter rod. With these dimensions, I used about 60 meters of wire for making the whole set, and which is weighted exactly 1 kilogram and 60 grams of copper wire, or something like that. 1 kilogram, 100 grams, or something like that.
Thank you very much.
But if you use thinner pipe, not a 10 millimeter one, but a 9 millimeter, for instance, probably will use less. So maybe 50 meters will be enough.
Yeah, this is Richard. I can confirm on that. It's about 60 meters.
Okay. So using 160 turns for the long one and 80 turns for the short one. Or to make it nicer, 162 turns for the long and 81 turns for the short. Because coils are very good to be a multiple of number 9. So number of turns shall be in multiple of number 9 for having the best matching. This is another theory. but it's a very useful thing to know. Okay, now the next thing which you have to do with these coils, when these are all cut, so you have to figure out how you interconnect them.
Shandor, there's a couple people that have raised their hands here that may
Yes,
have a
yes.
question. Let me just promote them, the
Yes,
panelists,
please.
so that they can speak or whatever they need to do. See, there's Leo Jokovic. Leo, do you have something you want to ask there?
Hello, Mr. Sandor.
Yes, hello?
Is that Emmanuel Spiteri? Hello, we can't quite hear you.
How are you?
Can't hear you. Try again. Sorry, your voice.
About the clockwise and you hear me?
No, we
Hello?
don't. We're not hearing you well. Maybe it'll settle out a bit, but there's a problem. Did you hear the questions, Chandra?
Maybe about the drill. So the drill can go left or right, clockwise or anti-clockwise. When I make the anti-clockwise coils, the drill turns clockwise. So the drill turns right always. It's like when you make a drill with a, or like when you turn in a screw. It's in direction clockwise, rotating, but because you're making the coil not coming closer to you, but going away from you, the coil will become counterclockwise. So that makes a difference.
I
So
think
the
that's
drill
what.
turns clockwise, right, technical right, the right direction.
Okay, about the diagram in the blueprint, is it right or is it wrong?
There
About
are
the
some
blueprint,
mistakes, there are some
diagram of the
errors. The text is correct, it says counterclockwise, but the pictures of the coil, it seems they need to be reviewed because they show clockwise coils and not anti-clockwise coils. So that will be reviewed.
Can you show the end of the coil closer to the camera, please?
Yes, please.
Yeah. The end part, yeah. Okay, wait a minute.
Yeah, we need.
It's hard for us to see there, Shandor. Do you have a? Well, it can. Okay, it's starting to clear up a bit.
Okay, it seems okay. When it finished, it's turning clockwise, isn't it? Isn't it?
It's
But actually-
anti-clockwise. So here I have the beginning of the coil and it's going toward my fingers. It's going away from me.
Okay, so it's anti-clockwise. Okay, I understand
Yes, it's
that.
anti-clockwise, and I have here another wire somewhere to show you more clearly. Can you see here?
No.
No, it's hard to see. You'd have to have it closer, I think. Then it loses focus. Oh, there, yeah. It had focus for a
You're right.
second.
Okay, I can see it now. I can see it. And what diameter of the bar are you using? Outer bar?
4 millimeter for the inner and 10 millimeter for the outer.
And when you put them inside, they are not touching.
No.
There's a bit gap between
Yes,
them.
because I do the nano coating not
When
by
you put
fire,
them-
I do by caustic, and it needs to penetrate.
All right.
Here is another example,
okay.
counterclockwise, so this you can see it better.
Okay, mine I like those. Yes. Yes, they are like that. Okay, because you have to point your finger towards you, so it means current is coming towards you, and it's uncoiling. So
No, it's coming from me and it's going to there, and then it's going anti-clockwise. So I am the source and that's the target.
Okay, and where do you put the longer part of the wire?
So the longer part of the wire will go inside itself.
Which end, please? Which end? Yes, yes, but when you started with a shorter one. So when you finish,
I start with the short. At the end, I have the long one.
long one.
Can I break in, Sandor?
Yes, please.
Everybody is confused about this long end of the inner coil that has to go through again. It doesn't really matter what part you take and you put through. There's only one hole to stick it in. So no mistakes on that part. No mistakes. It's an impossibility to make a mistake with that. So you can only make mistakes with making the coil counterclockwise or clockwise rotation, because when you make it around a rod, you wind it and it's fixed. It's or a counterclockwise or a clockwise. So if you make the mistake in making clockwise rotated coils, you have to unwrap or make new ones.
Make
But
new
you
ones
need
on the other
counterclockwise.
for the purpose. You make it.
That's right.
You may use it for making guns, for instance.
Yeah, for any other possibilities. So don't throw them away. I would suggest not throwing them away. But if you don't have anything else, unwrap them and recoil them to be counterclockwise. And with the extra wire going through, there's another orientation for that one. But we don't want to get confused with that. So that has something with the stacking and the orientation towards the total building of the 3 reactors.
Yeah.
But it has nothing to do with making the coil. It does have something to do with connecting the inner and the outer coil together, but not in this stage of making a coil. There's no difference. So there's just a counterclockwise rotated coil with a string going, with a wire going through it from the inner coil. That's it. No fancy stuff.
About interconnecting the coils, I think before to trim the ends, it's good to think about. Unfortunately, you cannot interconnect them before the nanocoating, but it's good to cut them at the right size before to do the nanocoating. When it's already coated, you don't want to cut it. You have to have it already ready. So here is a pair which I made. So this will be the position inside, the small coil in the long side. And okay, let me see, it's from which view to which view.
Sander, may I ask you something?
Yeah, of course, always.
Hello, I'm Leo Jukovic. Can you just confirm that the long edge, you know, that has to pass inside is only for the inner coil? As is
Yes.
Only the inner coil. Yeah? Okay.
Actually, to the large diameter coil, you don't need that 70 centimeters end. You can make it just a shorter one.
Okay.
So still you need something, because you will use about 10-15 centimeters. It will be winded over the other, and still you need inside the box to go from the bottom to the top to reach to there.
Yeah, for sure. That is obvious. Yeah. And if I just can add something, because that helped me a lot to understand the anti-clockwise and clockwise for people that are still confused. The point is, when you take the coil, any coil from any edge, because actually from any edge, so from the edge you got, if you go to the other side, it goes clockwise, whatever is the edge you have. So for the people to have, that's normally very easy to know what is clockwise and counterclockwise.
So you look from the top to it.
Yeah, you look from one of the edge. If you just take you coil, you just take it from. Okay, can you see my video if I plug my video here?
Yes.
Okay, I'm here. So you see, I just have my coil like that. Okay, and so when you see like me now, when I see from front, I can see that it goes counterclockwise till the other side. That's very easy.
Exactly.
If I take the other side, it's actually exactly the same. So there is no error possible. Okay, just I mean, I knew it. I know you knew it. You know it is just for people to clarify for the people.
Thank you very much.
Yeah, you're welcome. Thank you for clarifying too, Sandor.
Okay.
Yes, Sandor.
Sandor. So there's no difference with the longer one in the beginning or at the end. So because then you decide that you put the set inside the inner tube, you know, so there shouldn't be any problem.
Yes.
Whether I the 70 centimeters in the beginning or at the end. The
Yes. So now
longer one, you know.
when you connect the wires together, so you need here a length about the distance which is between the big coil and the short coil. For a short
1.5 times, isn't it?
and which you will wind on it, that has to be longer. So if I'm having this an entrance point for the big coil, for the larger magnetical coil, and I have here an exit point. Let's see where it is. Here is the this longer one. It's the exit point of this smaller coil. In that case, I make this maybe 4 times longer than this one to be able to twist around it maybe 10 times. So you can make them shorter, doesn't need to be too long. For the entrance to the system, I using a long one to be able to connect wherever is needed to circuit breaker or to the capacitor.
Okay, since you are using 2.5 cross-section area wire.
Yes, yes. And this is rather.
What is the diameter of the coil now, of the bigger coil? Since you are using
Here.
2.5 millimeters.
Just a second. With the
Yes,
spacing
and so
I have chosen,
how much is your diameter?
it's about 16 centimeters or
Millimeter.
6 inches. And for the inner coil, it's about 8 centimeters.
Okay, but about the
It depends on the spacing which you
diameter
have
of the
between-
coil itself,
But
not when you coil it.
what you see here, the spacing became just like the thickness of this blade. So when you turn it in a circle, here you have a bigger gap, and here you have a smaller. And this is just the thickness of this thin blade. And this is needed for caustic to get in. You see,
I'm talking about
holds it.
the diameter of the coil when you coil it
This
around
diameter?
the copper. Yes, yes, yes.
So if you had a 10 millimeter rod inside and you put this on, it adds twice the thickness of that wire. So this is 14.5 millimeters. So it's a little bit released from the tightness.
So it didn't make any difference because Mr. Keshe says it should be 12 millimeter, you know. But it shouldn't make any difference.
Yes, if you had a gauge 14 wire. And
Because yours
you get a
is big.
thinner rod. So you can choose different versions. So you can make it smaller, use less materials. If you use not a 10 millimeter pattern, but you use a thinner one.
And how much is the diameter of the inner one? Coil, same one.
Okay, so this inside the rod was 4 millimeter, and let's make sure, let's find the piece. Here is one. This is 7.2 millimeters.
Oh, it's all right. Larger than Mr. Keshe said, but it should be all right. Shouldn't make
Yes,
any
it's
difference.
approximative. It's not carved in stone, so it's not something very strict.
Okay.
You can make from thinner wire, from thicker wire. Of course, this gauge 14 was or 1.6 millimeter diameter was found as an optimal. Not
Okay,
wasting
something
too much material and still getting enough output.
very good. Something else about the thermostat protector.
We will
inside
come
the
back to
coil.
that also. So because the coils may heat up, you don't want to burn your system. So you need a thermostat switch. Which
Is it a thermal overload or just a thermal setting like MCB, you know, miniature circuit breaker? Because
yes,
MCB,
so it's very good to use it's very good
Like
to
a
use
circuit
circuit
breaker.
breaker, an MCB.
Yeah.
You have a circuit breaker with several contacts, which you power on, power off. You make the on-off switch, and when you turn it off, it will short the capacitors through a resistor to discharge them. It's recommended once.
because an MCB, if it trips, you have to reset it yourself. It don't reset by itself.
It depends on the construction, of course. So you have to reset it. So you need an on-off button. It will not reset by itself. It's
It should be okay. Should
you
be
can make
access-
your own circuit. So the thermal switch just gives the command to the microcircuit breaker whether to go off or on.
Okay, so if it's a 2 kilowatt rating, a 13 amp MCB should be used. If it's a 2 kilowatt, it should be about 10 amp. Sorry, a 10 amp MCB should be used.
Yeah, so I recommend according to the gauge of wire, if you use 2.5 millimeter wire, in that case to use a 20 amps or 25 amps.
Okay, all right.
If you have 1.5 millimeter cross section wire, thinner wire, I have here some also. This is the 1.5 millimeter, which is about 1.35, 1.4 millimeter in diameter. In that case, this is good for 16 amps.
Okay, we follow. Okay.
When you buy the wire, or usually in the box of the wire, it's written for how many amps is recommended, at least in Europe. And it's no reason to make a too powerful one if the wires in your wall are not so thick. So if your wires in the wall are 1.5, you don't use 2.5 here. Just the same to match them. And here you will have problem with finding a proper cord because these cords are 0.75 or 1 square millimeter, very rare 1.5 millimeter. I didn't find yet 2.5 millimeter, which is enough flexible, maybe a heavy duty one with 5 wires and not with 3. But you will need it if you want to plug, unplug, and outplug.
It's important the main cord should be 2.5 millimeter.
Yeah, it should be the same. If you make a stricture, if you make a bottleneck, in that case, the power will not go out. It will be reflected partially, and it will cause the heat up of the system.
And that thing Mr. Keshe mentioned it, they had to change all the main cords, you know, because
Exactly for this reason.
That for a reason, yes. Thank you very much.
You're welcome. Okay, let's go further. So when you will try to join the coils and you will start doing it, you will get your own questions. How to solve that? So the problem is that this copper wire, when you want to twist it, one on the top of the other, you have a short piece, just was showing, you try twisting it, and it doesn't twist well because it's very tough, you see? It's almost impossible to twist it correctly. You need a very strong power. And for that, there is an easy method.
Shandor?
Yes?
I have some news from Vince that Renan's going to be coming in to talk about the coil, and Vince says we are backwards.
Okay, this is very welcome, and we can talk.
So we'll see what Renan
I think
has.
it's about the interpretation of clockwise and anti-clockwise in different viewpoints. Yes?
I think it's 2 different coils myself, but
I
we'll
think.
Okay, that will.
I just
Oh,
found out-
we hear Vince. Go ahead, Vince. Sorry.
Okay, so I just found out that we have to think about the flow. We are concentrating on the wire, and the wire is what we're hung up on, and we're thinking about it incorrectly.
Anyway,
This
we
is
will
what I was
discuss that.
just told. So I wanted them to come in here so they can explain further, and we can get the questions that this is plaguing really a lot of people. So let's get these questions answered to the people that are actually making the units or manufacturing.
Right on. Great, Vince.
Okay,
let's wait for
meanwhile,
them to
I'm
come in.
consuming the gas beans, and you can continue afterwards, but I like to say what I'm doing here, and after that, I let the microphone to you, to Renan.
Go, Shandor, go.
So there is a trick to soften the wire. You heat it up to red color, and that softens, it anneals the wire. And you go slowly, start from the end and go to inside. Of course, it's more economical if you have a heat-resistant plate, for instance, a ceramic tile, a ceramic floor tile, and you heat over that. You will not waste so much heat like I'm doing now with the wire on the air. Because I have no such thing available here in this room. This is not a workshop, this is just a living room, so please consider. So we are going to heat up the wire. Maybe I need a bigger flame. I'm watching to see the red color where I'm heating it. Okay. And now safety. Never put the flame in direction of something flammable. And the second, the hot metal looks like the cold metal, so don't touch it. Leave it to cool. So you can speed up the cooling if you put it in some water, and then you will see the copper will crack off the coating of it. Yes, it's hot, so don't touch it yet.
Sandor,
Yes.
can you check when you are heating the copper? Can you check if the flame turns green?
No, it doesn't.
Because I think when it turns green, the temperature should be all right. That's when we used to use the soldering iron, the old soldering iron, remember, to heat
Yes.
the solder. And we used to solder wires. They used to tell us when it turns green, the flame, it means the copper is at the right temperature. I don't know if it applies to this
It
case
depends
also.
of the copper, and depends of the gas on the flame. So what happens actually, it turns green when the copper starts burning off. You see here that the flame turns red, not green. And it's really hot, as you see.
And the copper shouldn't turn red hot, you know, shouldn't turn red hot. Or else, as Mr. Kesha said, it will destroy
If
the...
you make heating for nano coating, should not turn red hot. But if you make heating not for nano coating, but for softening it, it shall turn red hot. Now we are not coating it, we are softening it.
Why?
Just I said before, this wire is very hard, and it's very hard to twist it when you make the connection.
Okay, I got it.
Okay, shall I put it under the tap water to not let you wait so much? Okay, so already I cooled it. Okay, when you work on them, usually you heat one, you put it on the floor or something which doesn't burn, not on your carpet. And now I want to show you the difference. So this end, it was not heat treated, this was heat treated. So now you see, I'm trying to bend this to a circle, and it comes to this one. I'm trying to do this one, it goes like this small. You see the difference?
Which one is the hardest?
This is hard, this is soft. So this will be easy when you have to turn one on the top of the other. If you will twist it so many times, it will harden back. You have to know about that. And you see, if you heat it red hot, that blackness will come off very easily. So what we want to see here, whether we can twist it easily, one on the top of the other. And that was our purpose. So now, if the wire is properly softened, just without using special tools, just with your hands, it's very easy to twist it. So before to do the nano coating, you have to
should be anti-clockwise.
you have to soften the ends of the wire over a flame to be able to twist them later when you have to join them together. See, now it's easy to make a twist.
Because it's softer now.
Yes, of course. And now, for instance, if I unwind it, we can measure how much length is needed for making a healthy twist of 1, 2, 3, 4, 5, 6, 7, 8, 9, or maybe 10 turns.
Are you using the electrical wire, the one you removed the insulation from?
I bought insulated cable, MCU 2.5, and I removed the insulation by using a potato peeler, so it's now uninsulated.
It's a bit hard, eh? That wire is hard.
Not magnetic wire, so not magnet wire, not a wire for transformers, which is enameled, but the blank copper, the bare copper. It's the bare copper needed.
About the magnetic wire.
Not good.
If we use that wire and then we burn it, does it burn the covering?
Yeah, where to burn it? On the street in the city of Budapest? It's not a good thing. Not a good idea. I'm in a blockhouse. I have no yard. And furthermore, burning those things, it makes a lot of poison pollutants in the air. It's not very healthy.
If I put it in an oven, you know.
Okay, what you do with the fumes? You can do it, of course. Many people do it. But it's a dirty job, which I don't like.
Okay. Do you think all the covering insulation will be removed from the magnetic wire by using the oven?
Try it. Anyway, the wire will get very soft, so it will be very hard to keep the shape of the coils. But it will be easier to make the coils. But if possible, get just buy some wire which is already a bare wire. So now let's see this portion. How long should it be? If I can straighten it,
That's very hard.
I will cut it here because I want to see this length, how much to be. I'm going to straighten it and to see how much. So about 10 centimeters, it's enough to make the coils. I mean to make the turns to connect together, for making a connection. About 10 centimeters is safe, 8 centimeters it's enough. Plus you have the twist it. Okay, now always go to the Gans production.
I think we should hear from Renan here, Sandor, to clarify about.
And meanwhile, we have so many questions which we have to reply later.
Yeah,
so
well, let's address the coils first, and then we can get back to the questions.
Yeah, so
I think that would be important to do.
Here's my understanding of clockwise and counterclockwise. So please explain your understanding of what is counterclockwise or clockwise.
I'm not sure if that's the actual question, but let's see what he's got to say about the coils. Hello, Renan. Hello,
Renan.
Hello. Hello. Oops.
Hello, Vince. Is Bernie there? Hi, Rick. Hello.
I don't see him yet.
I think he's there already. He's in the. Yes.
What is the name?
Bernie G.
With a V? Verna.
Bernie. V. Bernie.
I don't see a G in there.
Violet. Bernie.
Yeah, there's no V's. There's
VERNIE. He said he's there now.
Do you see it, Vince? I don't see it on your viewers.
No, I don't see him here either.
Show attendees. Let me see.
Make sure he's in meeting 939-474-503.
Okay. I'll re-log in siya, re-log in. He will re-log in again. I think there's a problem sa audio. It's going to re-log in.
And get him to raise his hand so it's easier to find him.
Yes, sir. Okay. Vern, please raise your hands.
Sandor?
Hello.
Yeah, hello. Sorry, it's Leo. Just a very short question. I just wanted to know if you nanocode the coils as
Hello,
they
Vern,
are,
can you raise your hands?
or if you disassemble everything.
First, you cut them, you adjust the ends, how long you want, and then, of course, the coils are assembled but not twisted together. You cannot join them together. Then you nanocoat them. After nanocoating, you put them into the soup of Gans, and after the treatment, you twist them together. And when
After you assemble them, yeah? Only after the Gans you assemble them together.
yes,
That's correct?
yes. And after that,
Okay.
you put on the places where you twisted, you put a few drops of cold caustic to repair any damage would be happen to the nanocoatings.
Ah, yeah, I remember that. But the units has to be disassembled to be nanocoated and to apply the Gans on it.
Yes, because if they are twisted together tightly, the caustic will not get inside the
Yes.
wires.
That's what I thought too. Okay, yeah. So that's a major and very important information for the people, because I'm sure a lot of people are nanocoating their unit already mounted.
Yes, so we are learning from our successful actions and from our mistakes too. Part of the learning from mistakes.
Exactly. I agree. Thank you for clarifying again. I stop the voice now. Thank you.
You are welcome. So please buy some copper wire in excess because it might happen that you will waste a few meters.
Buy some what? Did you say?
Buy some extra spare copper wire, not just what you calculate it's needed.
No worry. You know, I bought
happen
like
to waste
100 meters. I have 100 meters of copper. No
It's
worry.
very
I
good.
got it.
60
what I
meters for
need
the system, 40 meters for learning.
Yeah, exactly.
But you need also for capacitors maybe 5-6 meters. So
Okay,
we have
yeah.
70 meters for a system.
Yeah, that's it. I bought roughly 100 meters because I thought that I will use 80 meters globally for everything. So I took 20 meters extra. That I'm sure I'm on the good side. So
Very good. And with demonstration, I used up too much, so I have to rush again to do another coil of 100 meters to continue.
Yeah.
Capacitors.
I understand. Okay, thank you, Sander, for everything, and I'm still following your video. That's very good. Thank you.
Renan and Solomon.
I think we're still waiting.
Did you see him in the participants? Correct?
Yes.
He's already logged in.
Sendo.
Yes, hello.
Yeah, Sendo, your clockwise and anti-clockwise is wrong. I'm sorry. Maybe
No
it's my
problem.
mistake.
Please teach me.
Because if you start your coil from below, is counterclockwise.
Why you
But
start from below? I'm starting from my viewpoint of the creator and going forward away.
Okay, you just check your coil clockwise is starting from below. If it's starting from below,
I have no below. It's horizontal.
No, the long coil, the long coil. The long coil, if you're starting from below, it is counterclockwise. Yeah, I'm very sure.
I have no below and not above.
No, if you were to put your rod, Okay? If you go below, it's counterclockwise.
No, it depends of do you get the wire from left or from right. If you get it from right, it will come below. If you put it from left side, it will be above. You see?
When you start, if you go below, when you start, okay? When you start, you go below, it is counterclockwise. It is
Okay,
confirmed.
let me show you.
Yeah.
Let me show you. I put my camera here to clarify, because you are right and I am also right. Both we are right.
Okay. We learn from each other then.
Yes. So here is my rod. You see? And if I put a wire here in this hole, just I need a wire which is straightened. Oh, sorry, I have to use a new wire. Just I'm using now a solder wire for making it easier. Okay. It's too thick, it doesn't fit well into the hole. So you say, if I go from here
Clockwise.
and it's from above, you see, it gets this just a second, I have to break the wire. Okay. I have to pull it through, otherwise it will not work. Okay. I'm pulling it through. I start from above. You see, and I'm twisting it, and twisting, and twisting. So I will
you
have
can
from
see
here an anti-clockwise. You said it should come from above, but if it comes from the other hole, it will become below.
Yeah. So now you see your coil, the two coil is running anti-clockwise.
This is the purpose. I started from above, as you said. But earlier I started from the other hole, from the right side, not from the left. And if I turn that, it comes from below. It's the same coil. Just if I turn this one, you say it comes.
Because you are confused with the other side. You don't confuse with the other side. Okay?
I use this hole when I made the coils.
Yeah, don't
think about above or below. Look at the end result, whether that's okay or not.
Yeah, but you must see all your coil is the one that you're doing now. Also, is the running is clockwise or not clockwise?
I think we should clarify with Renan whether things are supposed to be clockwise and counterclockwise and so on to start with before we get into it more involved.
Can you see it?
Okay, Nana is here.
They're just angels.
Sorry, Sendo. We let maybe Renan can clarify better.
Yes, please. So I let this interpretation about clockwise and anti-clockwise, which I understood. And if you have a different understanding, please teach me. How is your understanding?
The understanding is not about that, Shandor, so far as I know. The understanding is whether we should be using counterclockwise or clockwise coils in the actual construction. So we should
all the week it was told all the coils shall be counterclockwise and counterclockwise and counterclockwise. This is I remember.
Okay, well, let's see what Renan has to say about that, because it's his pictures that were used in the blueprint that are opposite to everything that you've been teaching. So let's see what he has to say.
Okay, so Nana will be the one to present the proper coiling, what we are doing here in the Philippines. Are you there, Nana?
Yes, I'm here.
Okay.
Hello.
Can we see the picture? Okay. You can go ahead, Nana.
Okay, I'll just share I'll share a finished coil. Okay, here it is. Can you see the photograph now?
Yes.
Okay. In winding the coil, what part of the wire that you'll use to wind into a coil is the end or the straight part of the wire. You don't have to use as reference on the finished part of the wire, which is the already coiled part of the wire. So the direction of clockwise or counterclockwise should be on where you push that end of the wire to form a coil. So in this case, if you look at this end, if you'll continue this to form into another coil, if you face this part of the coil, you'll push this straight part of the wire so it will curl to form a coil in the direction that is opposite to that of the direction of a clock hand.
Okay, in your way, which is the beginning of the coil? Which is the end where you started?
When you start from the left side, you go to the right.
So this
so
is
winding.
Okay, this
is
winding.
You're looking at the end point and not at the starting point. That's our misunderstanding.
Okay, when you wind the wire, you have to start from the left going to the right. That's how you wind the wire. Then when you
just in opposite way.
By left and right, I don't understand what you mean by.
So the only difference here
going
is
right.
when we make the actual coil, the center wire has to be round counterclockwise, not clockwise. Is that what you're saying?
You mean the center wire?
Right, because you're wrapping it about in on itself, right?
Okay. No. You misunderstood the construction. When coiling this wire, you have a rod inside it. When you finish the size of this coil is based on the rod where you wind this wire, right?
Right.
Okay. When you start winding this wire, at first you have a straight wire. Then you move. Imagine there is a rod in here. You move below, then go up, then back to towards yourself, then all the way to the right. That's how you wind. When you face the movement from this side going to here, to the other side, you face this side, you'll notice that this straight part of the wire is winding on the rod in a counterclockwise direction or in a counterclockwise manner.
Right, and that makes a clockwise coil.
Yes, and it's been like that since the beginning of.
Okay, but we're interested in counterclockwise coils, not clockwise coils. That's the whole point.
Yes, we have to make the counterclockwise coils.
So are you saying these coils are correct or incorrect?
These coils are correct. We've tested this one.
These are what we consider to be clockwise coils. We've called these clockwise coils all week.
The question now is, what clock are you referring to? Are you referring to a clock moving towards the left?
This is the whole thing, is we shouldn't be referring to clocks at all when referring to threads of a coil or the winding of a coil. You don't normally say clockwise or anti-clockwise because if there's too many orientation viewpoints, you say either left-hand thread or right-hand thread. There's only two kinds of coils. There's right-hand thread and left-hand thread. That's a common known. It's just a thing they use all over the world as far as there's threads in bolts and nuts and screws that most of them are right-hand thread, almost all are right-hand thread, but you can get left-hand thread. They go backwards to normal threads, And normal.
Yeah, but we're not talking about threads. We're talking about winding a coil, winding a wire to form into a coil. That's why
Yes,
there's a term called clockwise.
for your wire, if you were to say that you have a, you got to have a convention. We don't have a convention when we're talking about winding clockwise and anti-clockwise, because it depends on if you're winding the rod or if you're winding the coil. They're both opposite to each other to start with. And then it depends if you're talking on the back part of the coil or the bottom part of the coil or the top part of the coil. That's opposite as well. So there's chances to make 4 mistakes in that terminology. So it's without pictures that are accurate, we're kind of stuck that way. And I'm not sure now whether the pictures are right or wrong. And what does Mr. Kesh say about this? I don't understand what's going on now. So we have to clarify this somehow.
Assuming it's a screw.
Is this the correct according to Mr. Kesh? Or is this the opposite according to
can I ask something? Is that the end point which we are right now looking at? Is that the end point of the coil?
Yes. This end point. This end point is the same on the other end point when you face the other end. It's just the same.
Both ends are exactly the same. There's no difference that
then
way.
when you wind this straight part, can you see the mouse pointer?
Yeah.
Okay.
I've got a question about this. How do you call this now? How do you call this
you
now?
wind this part.
For clockwise coils.
Yeah.
No.
Clockwise.
When you continue this, when you add another coil here, all you have to do is to push this part. Apply force on this part perpendicular to this wire. You push this so it will form.
No, we're not. We're not talking about the construction. We're talking about not like turn. Okay, if you want to make this on a rod and you turn a rod, you do the opposite direction into creating a the turn of the coil. We understand that, but the discussion would be. We're looking now at clockwise rotated or right turn rotated coils.
If they were a screw, they would turn right to tight.
That's right. And what has been explained was that we need a counterclockwise rotated coil for accentuating the magnetic fields. Am I correct, guys?
Yes, that's my understanding.
That's my understanding too. So we are actually looking into the counterclockwise rotation, but now we're looking only at clockwise rotated coils or right turn rotated coils you're presenting here in the picture. So the big question is, you're using these type coils in all your systems. What is your output? Does this function? Does it actually not matter if we go clockwise or counterclockwise? Does it really matter because we have this gravitational magnetic field difference? So I would really want to know now, does it matter to do it your way? That would be actually the opposite of being that was explained by Mr. Kesh. And then the question is, does this actually, give me your take on that.
Okay. During our testing, both winding works. The most efficient, that gives the most savings, is this one.
Wow.
We've been testing this one since August. Now you understand.
Okay, clockwise.
May I say something?
More output?
Why
more
don't
output with that? Or?
Why don't we just have one of the guys that in the Philippines direct someone right now, and he can wind the coils, and we can just see which way he says is the correct way.
No, it's clear what
clear. It's already very clear what they're doing. It's quite clear. We can see with the picture.
There's just a mess in explaining it now.
This photograph is on the blueprint.
Counterclockwise by pulling the wire counterclockwise, but it is a clockwise coil. It is a right thread, normal thread,
right-handed thread,
clockwise coil, because you trace the coil from what's facing you, what's facing here. You trace the wire down into the coil, and it goes clockwise when you trace the wire down into the coil. That's
okay, we agree on that. But the biggest question now is, why is Mr. Ashton, saying, that it's anti-clock? I don't.
Maybe he is saying it's anti-clockwise in the same way that they are, that you bend the wire anti-clockwise to make the coil, but it's actually a clockwise coil. That's maybe what he's saying. That's what we need to clarify.
Is it because he's left-handed, or?
It's nothing to do with left-handed or right-handed. It's a matter of this convention that people have mistakenly used of pulling the wire toward you when you don't know whether it's the top or bottom that you're pulling toward you. And this clockwise and anti-clockwise, like I say, it depends on your viewpoint. If you're looking at the bottom of the coil or the top of the coil, it's a different situation. And if you're talking about the rod that's rotating or the wire that's rotating around the rod, that they're both opposite to each other as well. So we have chances to make several mistakes with that convention of clockwise and anti-clockwise. And I think we should go to a different convention, meaning like right-hand thread, left-hand thread coil that we end up with. It doesn't matter what technique you use, as long as you end up with either whatever is correct, the left-hand or right-hand coil. And there's a chance that both are correct, like we were just saying. Maybe it doesn't make that much of a difference, but maybe it does. Maybe there's subtle differences with changing the emotional content of the room or something like that. I don't know.
Well, my interpretation of the way that Richard coils with that gun is because the spool is in front of you, you're kind of imploding the coil towards yourself. And I think that you're correct, Rick. That's where the discrepancy is coming from. Because the cord is on the opposite side of you and you're pulling it towards you with the drill guns. So I think the best thing that we could do is for someone to have both directions and take a look at them.
I think the best thing to do is ask Mr. Kesh and see if it makes a difference. And
right.
Rick, can I try again to show which one is clockwise and which one is not clockwise?
I think we pretty much figured it out, but sure, I don't see why not.
I need the photo from Sendor. Can I see the photo from Sendor where he show clockwise?
His video. There you go.
Yes, correct. So when you want to see clockwise or non-clockwise, you follow the center line.
So I consider which is clockwise and anti-clockwise if I'm looking from the top of the coil.
Yes.
And I follow the directional wire. So this conventionally I say it's a clockwise, like the clock turns.
Yes. But if you see
counterclockwise.
Then though, if you see from the center, is it the coil clockwise or anti-clockwise? From the center, the second twist, the third twist.
So this is counterclockwise, this is clockwise. And here I turned here a wire in both directions, just like twisting it from the middle to outside. So now can you tell me what is clockwise for you and which is anti-clockwise for you?
Okay, we start with the clockwise. The clockwise below.
Yeah. So this is
okay. You see the center and you wind it. You see whether it's clockwise or anti-clockwise. You wind. You follow the coil.
When I'm winding, I can go either clockwise or anti-clockwise, even though if I'm spinning the rod in one direction, it depends if I start here and go to right or I start here to go to left. If I start here and look, I'm turning this in this direction, you can see it. If I start the coil from here and it goes here, then the result will be a clockwise coil.
Sendo, you are correct.
From here, and if I go to here, it will get an anti-clockwise coil.
I agree with you. You see the long coil, you follow the coil and tell me if it's clockwise or not clockwise.
I'm not following the coil, I'm following the end of it to tell whether it's clockwise or anti-clockwise.
Sorry. Your drawing. You see your drawing in the center, from the first to the last, is it clockwise or anti-clockwise? You just follow,
This,
No, below.
This is clockwise coil. This is clockwise. This is the beginning and this is the end.
This is clockwise. This is anti-clockwise.
This is clockwise. Here is also, and this is counterclockwise.
If you follow the coil, it's anti-clockwise.
No, if you follow it, if you start at the beginning of that bottom coil,
it's also anti-clockwise.
No, you start at the beginning and follow it along. You don't move the coil. You're moving your eyes or your impression down through the coil.
It's anti-clockwise.
No, it's clockwise. You cannot go anti-clockwise down that coil.
From the start, you go from the start. Is it clockwise or anti-clockwise? From the very first coil.
I don't think the drawing is a help, to be honest, because it's not three-dimensional. So,
Shandor, can you make a big coil out of wire, a big coil, so we can see?
Yes, sure.
Like, about a foot or something in diameter, so we can really see what's going on here.
Okay.
Just found the part of the video where Mr. Cash is explaining it. Shall I share my screen?
Sorry, what was that again?
No, Rainer, just leave it there for now, please. Just hold it in the background.
Okay.
Now let's make a big one. So this is what I'm looking from here. I follow the wire and it turns counterclockwise.
Could you move closer so we can see,
Correct.
Shandor? That's why I want to know.
Correct, Sando. Sando, you are very correct.
Okay.
This is I call counterclockwise. Does not matter from which end I'm looking to it.
Correct. You are very correct.
Yeah. So it starts from here and it goes counterclockwise. And this is the other example. This is what I call clockwise. You see the difference?
Can I interrupt?
Yes.
Hello.
Yes,
of
please.
course.
We've been waiting for you.
Yeah. Okay. We're gonna settle this down tomorrow when I'm teaching. Okay.
So
tomorrow morning when we are there, we're gonna settle this clock and anti-clock. What I explained is correct. What all of you are doing is correct. It's just that when you set it, the rest has to be on the same condition, same rotation.
So if we go clockwise, all shall go clockwise. If we go counterclockwise,
yes. Positrons are positrons and electrons are electrons, and they still live and create field and gravity and everything else. I don't know why you lot suddenly got yourself bogged down in this clock and anti-clockwise.
It's no magic in it, just the directional field will be either this or that, it doesn't matter. Here we have an
a lot of people trying to, it's just by the picture. We show the picture, I showed it with hand, and tomorrow, first thing we do, we settle this thing for good.
Thank you very much.
Because the technology is confirmed, people are producing energy. It's just that, what do you call it? So if you follow the way it was shown, you should receive the energy. Is Richard online?
Exit ahead.
Have we got Richard online?
It should be, yeah. Richard, you want to unmute?
Busy unmuting. Yes, I am.
Hi, little young boy. What have you done? You achieved the power?
I was waiting for the coils to dry. I'm now actually setting them up and hooking them up and getting them on power. I've got the capacitors, I've got the coils. I'm actually in the process of making the first layer and going into the second set coil.
So you haven't tested yet?
I'm going to power it now or tomorrow. Let's say tonight or maybe in an hour or two, 3. We'll see.
Why is on the internet? Pardon?
Sorry, there's a guy on Facebook, he made already one, and he measures 5.3 kilowatts.
Yes. So what we're going to do tomorrow, we're going to sort this out for good. And you will go through it step by step. And by now, a lot of you should have achieved a lot of things with it, should be ready to test. So move on to the next step. And if there is any problem, tomorrow we will, what do you call it? We will show it, we will explain it. And if you do one thing, everything has to be in the same direction. If you do clockwise, has to be in the same direction. You do anti-clockwise, has to be the same direction. And either way, it should work. But then you have to look which end of the process you are looking for energy. Hello?
Yep.
Are we there?
We're still
Yeah,
here.
we're still hearing you.
Yes. So with this, we sort everything out tomorrow.
Okay, so
Great,
it sounds
great
like
to hear.
you don't have to take down the blueprint and so on with the...
The blueprint is there to show connections. The blueprint is there. The blueprint has worked. It works. It's different people are pushing different directions. Blueprint is 100% correct. There was a connection which was reconnected and gone back to be reconnected.
I meant, Mr. Kesh, I meant just with the coil direction, the clockwise versus counterclockwise, and which way they should be and so on. That's been the main thing. Many people have
We're gonna show it tomorrow. We're gonna show it tomorrow if there is any problem. But the strange thing is, has anybody winded it the anti-clockwise or the clockwise and it says it doesn't work?
Well, I'm not sure if people have their systems working yet is the thing, but many people...
Yeah, so we should have. If you have 2 coils, one is clockwise, one is anti-clockwise, you might get a problem. But if both of your coils are clockwise or anti-clockwise, you still should get a flux flow. It's a plasma. I don't know why suddenly this matter of physical interaction has come into it.
Right.
This is.
But it's good to good to stress that it actually doesn't really matter that you have a clockwise or a counterclockwise rotation as long as you are doing the same thing in one system, or counterclockwise
you
or
should get the
clockwise.
same result. Yes.
Okay. Is there a difference in performance? Do you already see that now?
Yes, you should see a small change.
No, I mean in performance in the 2 setups. Like, does the clockwise or the counterclockwise perform differently? Do we already have that confirmed?
Yes, you should see a problem.
Okay.
That's what we think. That's what we've seen.
Yeah, if you get the combination of the 2, you mean?
Yes, you see the problem is, Richard, some people are looking at it from the end of the hand they're making it. Some people looking at the end of the other end, the tube which is coming out.
Okay.
And I'm gonna put an end to this tomorrow, and we see if you need to rewind again, and we'll see, because I know in factory in Philippines they decided this is the wrong turning and they stopped everything and returned again. But in fact, it doesn't make any difference in the performance if everything is followed in the same pattern.
Okay.
Okay, that's good to know, because around 10,000 people a day or so are downloading the blueprints. So
yes, we're carry on motor. We settle this tomorrow morning. I'm gonna sort it out today. We are back home tonight, so we finished the room with all the jobs that came here to do. And I tested the car units and the power units, and the factory is producing them on the same pattern. So we'll see. Are there any other problems?
Well,
No, just the confusion about the coils.
Issue, and that was the big one.
The confusion came with the pictures which we put on the blueprint, because you're looking at the end of the tube where it comes to. And everybody looks at it and says, this is clockwise. How come it's anti-clockwise? And I showed it from the hand end. So tomorrow we're going to do it. We take it out of the blueprint the way everybody is happy. And this way we finish this case.
Good.
Thank you, Mr. Cash.
Thank you.
Discuss, you become master of winding. It depends how you conduct it, how you're going to do it. It's all the same. You have to find, if you make a tube and just turn it upside down, it becomes clockwise. What's the difference? We'll finish it tomorrow. We put the whole thing together.
I think half the point there is that we should have realized that it's the flow and not just the direction on which it's wound.
Yeah, because you're looking at the matter state. It's like in the factory, the workers don't understand, they're dealing with plasma. What they use clips. And
whoops.
Explain to them, how can you use clips? It's a plasma, it goes on the cover, not inside the material. So everything has to be dismantled and reorganized in a plasma condition. It takes a long time to change it. You see it, the way it goes, and then there's some people see it. If you follow the same thing in every direction, the clockwise or anti-clockwise, but it has to be, even the turn of your coils has to be, then it's okay. When you mix them is when you have the problem. You find a plasma clashing and then you have no flow.
But you might have something else at that point.
No, you just get a flux, but not that effective.
For that purpose.
Yeah, what about maybe we want to deliberately do that for a certain
If
problem?
you follow it the correct way, you should reach the powers the way it should be, and there should be no problem. If somebody has achieved 5.4 kilowatt, which we said with the double trap you can do, cascading is achieved, so nice for the rest to see what it is and how it's been done.
Okay.
We'll sort this out tomorrow. We'll address this tomorrow.
Okay, very good.
I think we can move on and answer some more questions then, if there's any other questions regarding the functioning of the system now that we have.
I think if any of you who are thinking in going into large quantity of Gans and you want to make rapid Gans, we can give you a few tips. That what you got to do is, for example, get yourself a small fish pump and blow air into your gas while it's getting produced. If you're connecting it to like electric power to produce high rapid gas, and that allows the oxidization much better if you can filter it with a high blow. So while you're producing, you're creating oxides. This is what we are doing in the factory. And the units which are coming out for production are the same. There's a lot of refining. This is one of the crudest ways made. We are learning in the process of manufacturing the shortcuts. But that's for production. If you're making one or two for yourselves, it shouldn't be that difficult. the beauty of it is it works now. We see people coming and reporting and getting, and the units coming from the factory working, representing their work. Tomorrow we finish with this situation that everybody understands. We can take everything off the blueprint, take everything off the net, and just put one blueprint to get rid of all the confusion.
Mr. Kesh, I have a question regarding the quick production of Gans. This is Vivek from Singapore. For the nano copper plate and the copper plate, when we put in a nano coated copper plate and a copper plate into the salt solution, we're supposed to get copper oxide Gans, correct?
You're supposed to get copper oxide Gans, yes.
Okay, so what happened is I have put in a nano copper plate and a copper plate into my salt solution, and I connected it to a 1.5 volt battery. Now,
yes, but the thing is, you have to. No. Stop. When you connect nano coated material or non-nano coated material, depends which way you put your negative and positive of the power.
Negative is going to the nano coated.
Yes. Secondly, when you use the power to the plates, if you're using like 1.5 amp, the material which is produced is not really idle. The ideal way is to allow a slow process in a box, copper oxide to appear. Fast production, it really doesn't make much difference even if you put a both non-nano coated plate.
Yes, because the Gans that I'm getting is actually copper colored, not green colored.
Yes, it's copper colored. That's a pure copper Gans. That's a pure copper Gans without oxidization. When you allow a slow process, by the time the nanomaterial separates from the copper plate, it's slow process so much that it already attaches itself to the oxygen in the water. And when you produce 1 or 2 amps or 1 amp and 1 or 2 volts, now you go so fast through the process that there is no time for oxidization. You get a pure Gans of the element. It's the first time man sees atomic structure in a tangible way.
Okay, in order to
this is not a good way. This is not good. If you have such a thing, blow air into it to make it green, to oxidize it.
Okay,
we have this problem in the factory. In the factory, they are producing rapid copper, and it's all copper. If you increase the current, we mix into a nano Gans condition, which is all black.
So I
we just create black holes.
Let it oxidize. I just have to blow air into it, let it oxidize.
If you leave it with a shallow water on the top, you will see that the top layer becomes green, it oxidizes itself.
Okay.
We've seen this.
Mr. Keshi, what about the application of hot caustic to the copper Gans?
What do you mean?
When you get the copper color, I've tried it before, you can use hot caustic to oxidize it.
You can do anything to it to oxidize it. But if sometime when you do that, you get nanomaterial at the bottom. Most of your material converts into nanostructure. You don't see it if you look at the bottom of your pot, it's like a black dust.
Okay, thank you very much, Mr. Kesh. I appreciate it.
You're welcome.
Thank you.
Any other question?
How to dry the capacitors?
Unique visitors since Friday. Today, Tuesday afternoon. 11,000 hits on group and site in the last 24
I'm going to silence, carry on teaching.
So about
did you get the question about capacitors, Mr. Kesh?
No, I just came on.
Okay,
I've
well,
been in the meeting all day in row.
no, I mean, Shandor just mentioned how to dry the capacitors was the question. You're breaking up there.
What's the question?
Okay, how to dry the capacitors. Did you get that? I don't think we're quite getting through here. Hello, Mr. Kesh. How to dry the capacitors?
What is the question?
The question is how to dry the capacitors. The plasma.
You don't need to dry it. If you dry it, you lose it. Just paste it on. It stays very pasty wet, and in time it dries up. But don't dry it.
So to let them wet.
Pardon?
So we just have to let the paste to stay wet and connect it as it is.
Yes, just paste it. This is what we do in the factory. The system works. The only problem you have, we saw even yesterday when we were assembling the new sets, is that your 4 capacitors you put in parallel then becomes like a shock absorber. It just opens up and closes. So you have to find a way that the 4 positive or negative side don't pull out. So you have to find a way like strapping the 4 capacitors together as one unit. We were looking at it yesterday in the factory. But capacitors are one of the easiest things to make. They are unconventional systems. They are not like a solid capacitors, unless you can find a way that you can hold the wires together without them vibrating or pulling out.
To avoid this to get off.
Right. How would you do it in your diagram there, Shandor? You got any ideas?
Yes, sure.
Put a wire across. Oh, don't rub it off! Oh, don't rub it off! You were there, Sandro.
It was beautiful, wasn't it? It was all there. Just had to connect them together.
Okay, so
put
how about to fix that?
Yeah, put 2 wires and literally push them through and wind it on the top of each other. You wind 1 wire over the 4 of them parallel, like you do in the circuit. Just wind the ends on the bars, on the 2 bars. But the only problem is, how do we keep the bars together that they don't open up? We are using fasteners.
So we need a mechanical fix.
We don't need one. What have you drawn now?
So is it possible?
Oh
to
yeah,
put
there are
them
4 of them, yeah.
either on block, either better to put them on a plastic plate and just to need here another piece which to be tightened over such a plastic part which is tightened with screws, for instance, to keep them to hold.
Oh, you can do it as fancy as you like, Sandor.
So mechanically this has to be fixed, otherwise it's easily pulling out.
It is.
I get the draft.
I'm sure we'll see different ways of doing it. I've seen people twisting the four together at the top and the bottom. Some people do it 2 and 2s. All at the end has to be in parallel.
Mr. Kesh?
Yes?
We had a question about the capacitors for the cars also.
For the car, you need only one capacitor, which is on the exit, on your magnetical.
Thank you.
You don't need 3 or 4. It's a single capacitor to stop a surge, and that's it.
So one of ideas to make from a copper wire this shape, which has 2 stoppers here, and then to roll the paper inside within these 2, and these 2 will hold the ends.
Making the plasma sort of go a little bit of an extra trip, though, isn't it? It has to go through all the. I guess it should be able to, but.
I'm thinking to make it something this way and to wind here, to roll here the paper with the paste in the middle, and that it will prevent to be pulled out accidentally.
They look like little antennas to me that might actually work in terms of receiving more energy or something.
Possible.
It might alter the configuration.
Another way, when you have them already made, assembled, you just can put them into epoxy resin.
992.
Is it okay to seal them up?
EVA 992.
Did you mute Mr. Kesh?
Yeah, I did that already. I was looking for the panelist button.
So one of the ways I'm thinking to use a plastic tube you put it in and you fill it with some epoxy resin, or just as Richard shown, he used over the capacitor just a shrink tube and shrink them together. Just question is how strong hold it has here on the neck to avoid to be pulled out. So
but,
probably
aren't they supposed to sort of dry out gradually by themselves? Isn't that sort of the idea?
Yeah, that's a question.
I think Mr. Kesh was talking about them as a paste, and you just let them dry out after that. And the ends are sort of kept open to air, but not so that it would ooze out or whatever. So maybe the shrink wrap would work well, and just not totally close the ends, perhaps.
Okay, it's easy to make. Question is which is the most economical way, because you may make here some mechanical support, doesn't matter from what, and you can tie together, for instance, 2 pieces of plastic and tie together with screws or anything to keep this tight here, to avoid these to be pulled apart.
Sandor.
Yes, please.
Sandor, your idea of the plastic tube is very good. If you were to nano coat it, and you have a cap where you can refill.
Possible.
Yes, and also I would like to thank you and Rick for being patient with me. I'm just a foolish old man trying to put a learning point.
No problem. Don't worry. No problem.
I think I got you. I think I got you beat on both the old and the foolish part. So
yeah, as long as mankind benefit from what we talk about?
Yeah, whatever we are talking about, we can learn of it. Having view
Yes.
that you can learn. Even
Thank
if
you.
something it looks foolish, at least it prevents you to do something to look foolish later.
Yes, correct.
Even something so simple as winding a coil, you know, it's more than what meets the eye sometimes.
Yeah,
So
different. Different cultures may have different ways to view things. For instance, in Europe, when we see a map, we see house blocks and we see streets in between, and we know to find an address by the street. So this is the main street. This is the old street, and so on. In Japan, it's a different culture. The street has no meaning. For them, street is something empty. It's a nothingness. They consider only the house blocks. And that's why they know this group of house blocks has a name, and this house block inside has another name.
Okay, Sendo and Rick, thank you very much.
Welcome. You're welcome. Okay, other questions? Still, we have some time of these questions and answers special session. And sorry for my desk is shaking.
Whoa, bandwidth issue.
Yeah, sorry for my desk is shaking. It's such a very light. It's a very light computer desk, and not very stable. So probably I have to buy a special stand just for the camera.
No, your sound broke up there. There was some bandwidth issue that totally made your voice turn into alien voice there.
Sorry, maybe I put my hand over the microphone, which is on the top of the camera. That's why.
Oh, well, that could have done it. Yes, that definitely confused the computer there. Okay.
So sorry for my image is sometimes shaking.
Right, it's okay. So we have a couple of questions, like the age-old question, which came up recently. Can you use the seawater and caustic to make Gans?
Yes, you can. You get some kind of Gans, interesting Gans. Even you can mix sea salt with water and to add caustic, it will give some Gans, but it's one kind of Gans only. We need many kind of Gans. You need a gradient of Ganses.
But not necessarily all the ones that are in seawater, because, for example, there would be chlorine. You may not want chlorine Gans in there.
No. You have chlorine in the salt. It's a sodium chloride. That's the table salt, yes? Already you have chlorine inside. It's no problem. You don't need chlorine when you do the nano coating, which is a different.
No, what I'm saying is when you put caustic into seawater, into salt water, you could get chlorine Gans out of it, which is not something you would want to have.
It will not do. So you will get Gans of different things. So we will get Gans of magnesium. So what's the most in the salt water, in the seawater? There is sodium, there is magnesium, it's a big quantity, it's potassium, there's calcium, and there are 100 other elements in smaller and smaller.
And well, the biggest one would be chlorine from the Cl. That's the highest level in seawater.
You have chlorine, you have bromine.
I've been experimenting with chlor, adding chlor to the procedure with copper copper electrodes, and that actually helps with the oxidization process. But I will not suggest just adding chlor to your procedures, because it can also create chlorine gas.
Yeah. So Mr. Kesh told once last week that
the thing is, I think Mr. Kesh mentioned that it wouldn't be such a great idea to use that kind of Gans, because it wouldn't be you're not controlling, you're not getting the three main kinds of Gans. Perhaps you might get dozens and dozens of kinds of Ganses, which is good to have that spread, but it may not be appropriate for the energy device, at least. Is that pretty much the viewpoint, or what would you say about that in terms of, like you mentioned, we can get Gans, but is it the correct Gans for whatever purpose that one
you have Ganses of lower order. You have
Well, I can confirm you later on, because I used to see Gans in the base paste I used to nanocoat my coils and for the capacitors. So I'll come back on that when my coils work or not work.
Okay. So anyway, it's good to have a mixture of Ganses, to have a gradient there. So now the basic ones which we learn to use, it's the CH3 Gans, it's the CO2 Gans, and it's the copper oxide Gans. And what we get from here, from adding together the atomic mass numbers, you get the strength of each. So this is 12 for carbon, 1 for hydrogen, 3 times, it's a strength of 15. CO2, it's 32 for 2 molecule, for 2 oxygen atoms, which is 16 each, plus 12 for carbon, it's 44. Then for copper, it's 64, and 32, it's 96, for instance. So you have a gradient. It would be highly desirable to have Ganses of higher value elements. For instance, to have of tungsten, to have of neodymium, to have of molybden or chromium or whatever else you can get, or from lead or of tin. So you may try to add to your Gans systems also some tin, or to add some materials which will release something else. So this is by its color. I can say it's a molybden color. It's a brownish color. It is a hard disks, repurposed hard disks. So I dismember some hard disks. So I got some magnets, and I got some steel plates which are covered on the top with a layer of molybden. The older ones were covered with platinum, which is also an excellent material. It's quite better than molybden, but it's expensive. You can use.
So there's a relevant question, Sandor. To make the very best Gans, what combination should we use?
I have no definition for the very best. It depends to which environment you want to have the very best. So these three have to be used. So it's a CH3. That's this orange color. You have the CO2 Gans. You have the copper oxide Gans. This is the green, bluish one. This is the copper oxide Gans. So maybe you can see the color better in this way. So here is the CO2 Gans. This is the CH3 Gans. It's very easy to produce it. Use nano-coated copper and some zinc-coated iron, like a zinc mesh or pieces of zinc-coated iron. And ideally, it would be to have some heavier Ganses as well. So that's why you may try with other things also. So always you match nano-coated copper plate with non-coated other materials. Or if you can manage to nano-coat other materials, that would be very interesting instead of just nano-coated copper. So you make heavier elements, Ganses, it means you have more energy inside. But for basic purpose, these three should be fairly enough. So you can get a very good system from that. And that has also advantages because they match also to the Ganses within the human body. You have the CH3 Gans, which is the base of all sugars. It's carbon and hydrogen. So that's matching to the emotional part of man. You have the CO2 gas, which is basically carbon and oxygen, and the carbon is part of the nervous system. And you have this copper gas, and the copper is part of the energy transmission for the muscles. We have copper in our body, very small quantity, but it's pretty enough. So if you have these three gases, you have connection to the entire being of humans or animals. You have connection to the nervous system. You have connection to the lymph through the copper gas, and you have connection to the blood through the CH3 gas. You have a physical, emotional, and soul level connection. Some more questions are here. David Flanagan asked. Thanks. Okay.
Mike told me that with electrolysis and CO2 GANs, you can produce a GANs of everything you want. For example, when you take two silver electrodes and make electrolysis with salt water with a little bit CO2 GANs, you will get silver GANs. Is this right?
I don't know. It may be possible. It may be possible just to use this electrically forced method. But you have to match the proper salt for it also. Not all salts will work with all the metals. You may try for heavier materials to use, for instance, not just sodium salt, but to use a magnesium salt, like an Epsom salt.
I'm using just ocean water.
Yeah, that has a lot of salts, so that's very good. That's already a good mixture. So it contains many other elements. I try to get a focus on it, and it's not easy. Maybe I have to change the position. Oh, it doesn't do autofocus. Okay, now. So this is a Dead Sea salt, of which was extracted the main edible salt. So it's a reduced sodium chloride, only 4 to 6.8%. It has a lot of magnesium chloride, calcium chloride, potassium chloride, magnesium bromide, and so on.
As Mr. Keshe always said, we have to use local things. So when you live near the ocean, just use the water of the sea.
Yes, so we are far from the ocean, so I was glad to find in a shop such a Guérande rough salt. It's from French producers. It's from the Atlantic Ocean. It's just a wet, rough salt. I have put some a little bit here into a plate to show you. So this is its aspect. This is a full, complete ocean salt without anything extracted of it except water. Still, it has a lot of water. You can see the big chunks. Of course, when you dissolve that in distilled water, you'll find some foam floating on the top and some mud going to the bottom. You filter those out. You don't need those. And you have a very good ocean salt. Okay.
Hi everyone, it's Modris.
Yeah. Yes, please.
I just want to add a bit about the seawater and caustic, because there has been many studies done, and what they find that like they was using specific way how to find what is in there. So first of all, when they was testing, they was using some kind of burning type of method. So they was finding first huge amount of silica inside. When they was continue burning it, they was finding the gold, then platinum, the rhodium. Basically, they find all platinum sort of metals inside. So in ocean water, there is all elements inside. It just depends on which amount. And what they found about gold, it was about 30 times more than what they usually find in the mines. So only think like when we make the copper oxide, like we know it's more or less pure. And then I was quite puzzled about that, because if they was using the burning method to figure out what, I thought maybe they was just opening up the plasma. So first there was silica, when they was burning and like applying the heat, I mean it's plasma energy, they was start to absorbing by opening the plasma new elements, which was deeper, you know, with heavier mass. I mean. So, but anyway, what we know in ocean is everything inside. So just I wanted to add about that applying the caustic on the seawater.
So life organisms have inside their body ganses, and we have to know that all life started on this planet in oceans. So the salt of oceans is very favorable for the life forms which we have here. So,
and don't forget fishes. Sorry.
Go ahead.
Fishes, they do poo there as well. So there is B12 and all these vitamins inside as well, which comes out.
But you also got to keep in mind that if you were to, say, drink a quart of salt water, you will find the results are quite amazing and unexpected, let's say. So the body doesn't do well with just taking in salt water from the ocean. That kind of salt is not tolerable for, that kind of water is not tolerable for the inside of the body.
It's not to drink it. It's to
So that's why they was applying the caustic like that. They was separate the salt from those monatomic elements like Gans, and like that. When they was like promoting this sea extraction, there was peoples was absorbing like in 45 days, release from the cancers. Because and from what Cash teach, people dying not from the cancer but lack of energy, and when they ingesting those things, actually it gives so much energy, so you can keep running. Your body is boost again, and it's have immunity back. So about the salts water.
Okay. Getting a lot of background noise here from your microphone there, Mo.
Yeah, strange. Now it's better?
Yeah, it is actually. Thank you. Oh, still is. It's okay. Okay, any other questions? We got some questions here. Chris mentions when you're using the butane gas coating and then you Gans the wires, the Gans would not go in between the windings. What about this? I think there's a gap in the wires when you do the Gansing, you dip the whole wire assembly in the Gans. Is that basically correct? You have some input on that.
So yes, I used to make a spacing between the turns of the coil with purpose to let the stuff go in. I think it's better if you use a wet process of nano coating. Meanwhile, Renan told that in Philippines they use this fire nano coating, and it creates the coating inside. So we don't know how much it will soak in the Gans from the soup. So
I did one. Sorry.
So probably after heating, the wire gets softer, gets loose a little bit, and when they form it, shape it by hand to be round, some gaps will still exist there.
What I did, I was heated. I coated with heating, and then I put on cold caustic. But I left the wires completely cool down. Then it doesn't lose that black coating. And then I left in cold caustic overnight and have beautiful coating. Because it's like if there was something loosen it, it's with the caustic. It's kind of goes deeper, and it's made quite nice coating.
Yes, so you can start the process with fire if you have too much gas to waste or charcoals.
I use it home gas.
Ah, it's okay. We have electric
Right.
system, not gas. We have no gas here, so not everybody has that gas. So anyway, there are many ways how to make the nano coating. So one of the ways which I tried it, I put in a caustic solution, the plates to be coated with the negative wire from a battery or from a power source of around 2 volts connected to it, low voltage anyway. And I put the positive wire on some neutral electrode, which can be stainless steel scrubber or a piece of carbon, whatever you have. And you let the current flow through that liquid, through the copper piece for about 30 minutes or an hour until you see its surface became uniform. When you take it out and you put it into your plastic box, just hang it to let it to condition, and it will still make a beautiful nano coating. And just in this case, it's a combined effect of caustic and the electric current, which helps the removal of the top layer of atoms from the surface of the metal. And these top layer atoms, when they depart, not all can leave it, just many remain very near in proximity to the plate, so they get attached through the gravitational magnetical fields, and that's why these nano layers are created. They are created from atoms which got released from inside. When you heat, also you release atoms. When you put caustic at high temperature, also it releases. When you use electricity, also it releases some. So there are different methods how to do it. And the most beautiful method we'll have when you will have a good plasma source to just connect them, the copper pieces to the plasma source, and to let the plasma coat it. That would give the most stable nano coating. So there are different ways anyway. I wish to say about the connecting the coils. I've seen there some early versions which were different, but this we clarified with Mr. Cash on Friday afternoon workshop, how this have to go. So you see the minus, the conventional sign for the entry point, and with plus you see the conventional sign for exit point. And we call conventionally the inner coil, the smaller diameter coil, the thinner coils as gravitational, and the thicker coils, which are marked here and drawing with red, we call them magnetical. And now, if you follow the flow of energy from entry to exit, you interconnect the wires always. First, you connect the smaller diameter coil. Then it goes from viewing from the top, it goes clockwise. Then it's continued by the blue wire, which is the long end of that coil. It goes again through itself, through the coil. That's the second turn of the gravitational circuit, again clockwise. Then it goes to the longer coils. And also it gets first into the thinner coil, not into the thicker one. Again makes a third turn clockwise. And then you have again, which is marked here with blue, the long end of the coil, which goes again through itself. And then after these 4 turns, you finished with the gravitational part. And from here on, you connect it to the magnetical, but not to the right hand, but to the left hand, and you start flowing the energy counterclockwise through the higher diameter, through the thicker coils. So you go one turn anti-clockwise or counterclockwise, then you connect it to the outer circle, and you make the last turn, and you reach to the exit point. So you see you have 4 turns in the, one direction, which is the gravitational, and 2 turns on the magnetical coils, which are the magnetical. So the gravitational action, the gravitational field forces will be stronger. So it fulfills the conditions of preserving the free plasma inside. Are there questions regarding to that, or is it all clear?
I think, excuse me, I think so. Just so that people know that there is the central wire, and well, you can leave that picture up there if you want, but the central wire, then there's 2 coils around that central wire to make up just the inner, and then there's a central wire and 2 coils around that wire that makes up the outer coil as well. So it's not quite clear sometimes there, but thanks for saying that, Shandor.
So I may try drawing it again to let's rehearse it a bit. So we have an entry, which we mark it with minus. This is the entry. And this is the conventional direction of the energy flow. We go always first to the smaller diameter coils, then we will go later to the bigger diameter coils, the thicker coils. So the thinner coil, which comes here, this is the inner coil. Of course, this is a coil here. We have this termination and goes again through it. So this is the second turn, and here it comes out. So you have here twice 2 turns for the gravitational. Then you enter into the next thinner coil. You go through. So this is the third turn. And the end of it, it goes again through the middle. And you get here an exit point. So this is the 4th turn in gravitational direction. From here on, we start following in opposite direction. So we go into the larger diameter, into the thicker coil. So this turn is just in the opposite direction. If this was clockwise, this is counterclockwise. And from here, so always we start to do the circle inside, then we go to the outside. And from here on, we have to connect to this one, which makes the outer. And here it goes, second time, again clockwise. And here is the exit. So it looks complicated because so many circles, but in fact, you have entry, you make 1 turn through the coil, 1 turn through the wire, you go to the other thinner coil, you go 1 turn with the coil, and the second with the wire which is inside, and you connect it then in opposite direction of flow to the thicker coils, counterclockwise, once in inside and once outside, and you have the exit point. So that's all. you'll find it's a little more complicated about how you connect together the wires, because these are not made of one single wire, but there are several wires that we have to connect them together. So as a basic rule, if you have an entry, a minus from one, so it's an entry point, and you have an exit point from the other, so this is a plus, then this has to be twisted over the other, and the end always is terminated in a loop. So you end the wires in a small loop to not let the energy flow out, but to turn itself to itself. And here, when you make this twist, use the same direction of twist like you did for all the coils. So it doesn't matter they were all clockwise or anti-clockwise, because we had such long discussions earlier. But in the same direction you made these coils, in the same direction you have to make this twist when you connect together the ends of the wires. Okay, is this clear all? May I delete it?
Yes. Thanks, Shandor. You just answered a question on the live stream with that.
Okay. And then how to connect all together. This will be the next thing. You have a central sun. This is very important for every coil system. So we have a small sphere or a globe, which is filled with Gans, and the globe itself shall be nano-coated. So it's the magnetical field of nano-coating which holds the plasma energy of the Gans inside. So then you have the coils which are here. I have to make them bigger just to keep the right proportions. This is the next. And then you have the bigger coils around. Something like this. Very large schematics. Now, Mr. Cash told us that you have the diameter. Let me use another color. You have here this diameter of this inner coil. You know, the smaller coil, the shorter one. And this diameter shall determine the distance between the top and the bottom of the system. So if you have here this diameter, that should be identical to the height of the system. So if this is 8 centimeters, for instance, this also has to be 8 centimeters. If this is 5 centimeters, this also has to be 5 centimeters. And the connecting of the wires, it's very easy. You have entrance, which goes here. You have an exit, it goes to the next entrance. You have an exit, which goes to the next entrance, and you have the exit here. So this is about the coils in the system. And when you have all these three connected together, you make the connection to your wires. Somewhere you have to put your capacitors here. So I'd like to share the pictures from the blueprint about that. Let me find the proper file. Yes, I found it. Just let me share the screens. So this is how these are put together. So you see, if here the gravitational loop is 5 centimeters and the height between the centers should be also 5 centimeters, 2.5 and 2.5. So if this will be not 5 but 8 centimeters, where you have 4 centimeters and 4 centimeters, total 8. This is construction of the plasma capacitor. And here are different configurations, how you connect the capacitors. So you can, for instance, make just like a bus with entry and exit. You have here the AC power grid in one direction, you have the load in the other direction, and you just interrupt and you put in series your MAGRAP system on the live wire. And for the live wire, you have you will need such a phase detector, which was a big question for many because there are so many phase measuring instruments, and this is a very simple tool. It's a small neon lamp inside a transparent screwdriver in series with a 2 mega ohms resistor. So you put this into the on the wires, and you touch here this with your finger. You will not be shocked because of the 2 mega ohm resistor will reduce to a few microamps the current which goes through. And if you reach the live wire, then this should light up. So those who work with electrical things, they are accustomed with it. So I have 3 wires here. This is the earth, it's nothing. This is the ground, it's nothing. And when I touch the live, then I have here a small red light. You see, this is the live wire of the 3 wires. So this is how to use it. Okay, so back to our screen sharing. So one of the ways is to put in series with your live wire the system. There is another way which is very similar, but in one case you have the capacitor to the load side, and the other you put to the power grid side. Does not matter, it works. Or there is the third version, it's same connection, but you put the capacitors here between the entry and exit of the MAGRAP system. So all these systems work, and there is a combination of them, and so on. In case if you use, you make a unit not for the power grid, for the AC power grid, but for your car or for your boat. In that case, it's very simple. You put the capacitor not in parallel, but you put it in series with your circuit. So this is the way to do it. And if you make a very complex system, you may consider to use a circuit breaker to power it off or on. And when you power it off, in that case, the capacitors get discharged through some contacts here. So it's all about it. This is a test setup. Okay. Any questions about the wiring?
I have a electro scooter.
Okay, you use the same settings like in the car, I suppose.
Well, but will I need the batteries?
Yes, sure, you need. So this system is not a substitute for battery. It's adding power to it.
Well, if all goes well, then hopefully there'll be plasma battery type systems that will be offered in the up and coming, hopefully short time.
That will be in the near future, yes. Okay, soon we reach 5 o'clock, so soon we can wrap up, but there are still some questions. Maciasz asked, Carl, does your reactor works? So it's question to Carl. Who is Carl? So it's not clear to whom he is addressing the question. So very
I think he means Kalel.
Yes, but it was K-A-L, not Kalel, but anyway. So anyway, soon we will get many reports of people who are building the reactors right now, and after they'll put them working, they'll be happy to share together with videos, photos, and sharing their results. So it's no reason to make us for us to make a demonstration about these commercial MAGRAV units, however they work, because always there will be skeptical people who will suspect that there is a hidden connection to a power source, or there is a battery hidden inside, or we are feeding with radio waves from the exterior, and so on. So best is if just people get the knowledge how to build them, people make them, and everyone will have the result according to his own hands, his own work, and they will be happy to share these results. So EMC version 2 asked, so strange names. Since the argument of clockwise and counterclockwise is inconclusive for now, why? It was very conclusive. Does not matter just to be uniform within a power unit. If I wanted to test both directions in different system, what might happen if I connected both systems in the same house but on different floors? No problem. No problem will happen. Bernard Langlois asked, I have asked about gold Gans. My tests have shown it to be very powerful. It seems to draw all the fields, but not sure if it will release the fields. So that's very interesting. If you are reaching gold and you create gold on, so do the tests and please share the results. I have no. Yeah.
Shandor, people are asking on the live stream to
yes.
Show the capacitors. Yes, the capacitors. Can you do like a 1 minute, maybe 2 minute at most crash course in capacitors?
Yeah, I have the proper materials for it. Just I can show it with some other materials about how to make it. So
or you can
I try to make it in the front of this whiteboard, so maybe it will be more visible. Have some contrast here. So we some straight wires, and this will be nano-coated copper wires. So it will not be this solder wire which I'm using. So I'm using solder wire just for demonstration purpose because it's very soft and I can straighten it many times. So you need 2 pieces of wire. So one of the wires, you just make it in this shape to have the end closed in loop, so you don't let a sharp point pointing out. So this is one of the wires. You get a piece of not such big, such about this size of parchment paper or baking paper. You put on it paste. So you fill it with Gans paste, pretty dry Gans paste. A very hard Gans paste is needed. So those who used to make cakes, they are used to spread chocolate cream on the cake, or in the same way, like you put the peanut butter on your bread, you just put here the Gans paste. And then you put the wire inside, and you start rolling it together with the paste very tightly. You just keep it rolling, rolling, and rolling until you finish the entire piece. Okay, such a palm size, it's enough, doesn't need to be much bigger. Then you take another piece of nano-coated copper wire, always the ends to be twisted back in this way to avoid energy loss. And then you just twist this over it, and if you did counterclockwise coils, then you make this also in the counterclockwise direction. Just I don't have enough long wire here. If you have longer to twist it more times until it's filled completely, it will be good. So we have an entry point and an exit point. So this is about how to make capacitors.
Do you need to insulate it, Sander?
I can't believe you made it in 2 minutes, Sander. That was amazing. And people are loving it. Ruth says, love it, crash course in capacitors. She was one of the ones that was asking that question because she takes notes. Yeah. So thank you very much.
You're welcome.
Thank you, Sander. And you know, what about the insulation, the distance between the capacitors? Is that's so it's 1 centimeter, 1.5, or
between the capacitors?
Between the capacitors?
What do you mean?
Well, that's what Mr. Kesh said. You need to, you know, separate. They should not be in touch with one another.
Okay. Mm-hmm.
So you leave some space.
And we need to leave
or this space, doesn't matter.
So we need to wrap things up for today, and there might be a few less loose questions, but that's all we can really handle, I think, for now. Anything else you'd like to say, Shandor, to wrap it up?
So thank you very much for participation, and tomorrow will be Wednesday, and on Wednesday morning we start again to continue the blueprint week. And hopefully, if you have made your MAGRAV systems, or if you have made some parts of it and not yet finished, please come and share with those photos and videos with us. So more people come, it's much better. Also, we have this blueprint website. Rick, do you have the exact URL?
Just a minute.
It's a blue.
The one that people can put their pictures on, you mean?
Yes, exactly.
Okay, let me see.
It's a blueprint.cashfoundation.org.
Right.
Just I can't get in.
I've got it. I can share my screen here. Just a minute. And to let people know that this will be what we'll be doing tomorrow as a public workshop on this same channel, basically the blueprint channel.
Yes, and please don't send us pictures. Don't send us pictures. Don't send us videos. Upload your pictures, upload your videos on your favorite social media website. Does not matter in Baidu, on Google Plus, on Facebook, on YouTube, or on Vimeo, does not matter. Just upload it to some public place where they can be shown without restriction, and just send by email the link to them. So send email to blueprint@cashfoundation.org. Please include your name, your location. For instance, I am Shandor, I'm from Budapest, Hungary, and here are my links. So, you send the links to your Facebook page or YouTube page or Baidu or whatever. And then the webmaster will put up on this website on blueprint.cashfoundation.org your experiments and your results, and everybody can learn each from the other. That would be a great contribution.
And this is not to be confused with the other blueprint site that has the actual blueprints.
Yeah, that's linked on the upper right part. Is the MAGRAV's power blueprint link.
Right up here. So folks can see that. I can click on that. And that gives you the download link for the MAGRAV's power blueprints, it's called. This is version 2.0, and there'll probably be version 2.01 or 2.3, whichever upgrade we go for in the next little while. We'll try to keep that, I think, as a live document that gets upgraded as we find issues or discover new things that can be added to improve it as we go along. This is sort of a crowd sourced item in a way. We have manufacturers that are making it, but at the same time, many individuals too. So we can all collaborate to make a better product, I think. Okay, I think we should wrap it up for today. Thank you everybody for attending. It's Tuesday, November 3rd, and the afternoon teaching of the Keshe Foundation Spaceship Institute. And we'll continue tomorrow. Okay, bye for now. Stop the live stream.
Thanks to all of you. Sander, Rick, Vince, great work.
Thank you. And Emmanuel Dus just has a last question. He said they would like to meet Mr. Keshe for the creation of Keshe Foundation in Switzerland, if it's possible. So please, we don't reply now to your email, which is on the chat, but please write down nationalkf@keshefoundation.org. That's the email where the requests for creation of national or local Keshe foundations are handled. So please write an email to nationalkf@keshefoundation.org.
Thank you, Chandler. Good point. Okay.
I did see Bernard had his hand up there, and I brought him in here. Bernard, did you want to say something? Are you going to be showing anything tomorrow, or do you have anything ready? Can you unmute, Bernard? Can I unmute you? Bernard, are you there?
There you go. Can you hear me?
Yeah, I can hear you.
Yeah, this is all new to me. I got a new Mac here and just getting the feel of things here. No, I was going to show a few things about the capacitors, how I wrap them and stuff, but that's okay. We can pick it up some other time.
Right, that's why I wanted to bring you in here before we left, is so that, how about tomorrow? Are you able to be there tomorrow?
Yeah, tomorrow I'm going to make a point. I got on late this morning because I didn't know if things were going to happen today there, but it's been good anyhow. I do have questions about the gold Gans. I've used this before, and well, I had my electric clock going backwards. It seems to draw the field. The power of it almost scared me.
Whoa.
Yeah, no, this is wild. I had to take it out in the backyard. I didn't work with it anymore.
How you have prepared it? How you made it?
Well, it was just gold Gans. I dried it and I added in some nano paste I was making. And
how did you make the gold Gans? He's asking.
Oh, I posted that a long time ago. You make it with the nano copper plate, and I had a gold chain, and I use
such a piece of gold chain or gold ring.
Just a gold chain, just a small gold chain I wrapped around, and I use rare earth magnets. So the wire going from the gold chain to the copper plate, the nano coated copper, I put the magnet between the two of them, and let it go.
Yeah, same as Eric Olsen has shown us.
What was the magnet in the solution?
Part of it was in the solution. You have to watch it after. It'll go for a while, but then it'll start to decompose, and you get CH3 from it. But you watch it until it gets to that time and your Gans color, and then you just stop the production. You remove the magnets and draw off your Gans. That stuff is really powerful. I rinsed it up, and I haven't used much of it since I had that experience. I made some capacitors, and while I'm making them, the charge just went through the roof when I first tested it, and then things seemed to dissipate, and then I had some Gans outside, but there was...
Bernard, the thing with the gold Gans would be the fact that it's a much higher mag-rev strength, if you want to call it like that, than copper, right? So the point is to get the
only problem is Mr. Keshe mentioned that it draws all the fields. Well, I tried this, and it draws, but it may not release the fields, making it not really a viable, product to use. It'll suck everything up. I know I had to move. I had stuff outside the house, and I was inside the house, probably 6 feet between myself and what was outside on the deck. And my clock started going backwards. It was hanging on the wall between us. I had some outside and I had some in. I finally just took the capacitor I was making and took it out to the back 40 to get them away from the house. It kind of worried me. This is a while back, before we knew what we knew about plasma fields and what we've learned so far.
You haven't coated any copper.
Pardon me?
Wires with the gold Gans, or with a mixture of the gold?
Well, right now I've got some gold. I put a little bit in a saucer and I put it in the oven on low heat, and it'll dry quick enough. I'll crumble it and put it into the nano state or add it to some nano paste. This is basically what I've been using for my capacitors. I use caustic, a little bit of vinegar, and the dried Gans, or even some wet Gans when I'm nano coating stuff. I'll add vinegar. And
wait, but for coating the for Gans coating the nano coated wires themselves, coils, have you used that?
No, I haven't tried that yet. No, right now I'm drying some stuff out here, and I'm going to see what that does. I take a small portion and do a few more tests. If things start running backwards again, I'm just going to stay away from it.
Do you have your coils made yet?
No, actually, I've been working on medical stuff. It takes a little bit of work to make the pads and different things I make. I've got some capacitors made. I make them pretty regular. I'm constantly testing. I've got my hands in too many things, I think. The coils are pretty easy. For me personally, I find them simple. I just set up in my shop and I'll run them off. I've got another thing I've been working on. I've been focused on that, but I've got a big place to look after myself, and I've been trying to get ready for the snowfall up here.
Right.
Got a question for you.
Yeah, go ahead.
If the gold Gans makes your clock go backwards, have you noticed yourself getting younger lately?
I wish that were the case. Maybe a little bit of hair. But that was a few months back. That was back in the summer when I had worked with this, when we were first creating the nano paste. And I tried this, and I made a few capacitors, and the initial charge, you know, it would send a charge right through the ceiling on the capacitor. I said, wow. But then it would start to dissipate, and I had a few of these made, so there was fields. There was fields that were present. And then at one point, I could hear my clock, and it's going the other way. I said, what the hell is going on? It's electric battery powered, just a 1.5 little battery in there. So, and when I got rid of the stuff, I never had that issue again with the clock. So there was some interference happening there. It was drawing fields from all around. I have a few reactors running. And
was it? Do you think it was affecting you? Do you have any physical symptoms at that time? Were there anything? Did you have headaches or?
No, I didn't get any of that.
Were you enthusiastic and more?
I was at first enthusiastic until the clock started running backward.
Stop watching the clock. That's obviously.
Now the capacitors started to lose their power. So the only thing I could figure out was this gold was sucking all the fields from around and not releasing it. So I don't know. I've got some more stuff going. I'm going to give it another crack. I'm going to mix it as I've got some nano paste, quite a bit of it. I'm going to try and do a few tests with it and see what happens. As far as the coils, I have no coils to show. I've run coils when I hook my. I've got a setup I'm using a series of coils. I use zinc copper wire that's coated, and I use counterclockwise with clockwise rotation. The clockwise I use as my negative pole, and the counterclockwise is my positive. It seems to be carrying a charge. They're wired in series, so we'll see what happens. I'm still working on things. I've got a little reactor myself. I don't want to make waves and get in the way with things. What's happening right now, I'm just going to go with that. I get a minute.
Would you want to do a little presentation tomorrow, perhaps, if we have, if the opportunity's there, if there's an opening? I'm not sure what Mr. Cash has in mind. He might just go gung-ho the whole time with some concept, but there might be an opportunity to present things. It'd be good. We don't have too much lined up right now, so.
Well, just the capacitors, the way I build them, it's fairly simple. Yep. I use a plumbing tape. Pardon me?
Sorry, I mean, it'd be great to see your way of doing it, and you can get comments from Kesh and others and questions and so on. It'd be good fun.
Capacitors I make are basically the same as everyone else's. It's just the way I wrap them. I found the plumbing tape to be very efficient. I just split it in half with a pair of scissors, and it stretches. So it's very soft. It doesn't distort everything.
Mm-hmm.
That's pretty much, you know, I'm not show there. I've got some health belts and different things. Right now I'm working on some more stuff. This is taking up my time. I've got friends that are back pains and different issues, and the pads and the CO2 things I've been using. Well, I basically healed a dislocated shoulder that was headed for surgery. Did that quite quickly.
Well, it'd be great to hear that kind of story live.
Yeah.
Especially love to hear that.
So that's why basically I haven't been working on the power units. I do have one running downstairs. It's been running for about 2.5 months. There's stuff happening, but as Mr. Cash has stated, I watched my meter drop 400 points one night. Next morning, the smart meter, they were onto it. Then I started paying for the damn stuff. Excuse my French. So I mean, it's an unorthodox way. I did post a video of it. I'm using a 3,000 watt inverter and a battery charger onto the battery and that sort of system. But this is more for test purposes. The other system I'm working on, and Mr. Kesh's the system you've got out now is very good. And I'm going to gear up to produce a few of them. And if I can get more people interested, you can't be a preacher in your own home. You know that.
I haven't heard that term before.
Yeah, well, you've got to go at least.
I kind of do that though.
Yeah, well,
I preach from my own home.
Yeah, they don't like that too much.
Yeah.
But people I meet,
if I may just jump in and ask a question.
Sure.
When you saw your clock going backwards, do you think that could have been sort of a time modification effect or something to that extent?
No. I have really good memory. I don't write things down, but Mr. Cash did mention, not too much. We didn't elaborate on gold, but he mentioned it draws all the fields. I did ask about black Gans, well, probably 3 months into the knowledge seeker thing. I had happened onto it, and I knew how to make that very quickly. But the gold itself, when he said it draws all the fields, I didn't know if he draws and holds the fields or if it draws and releases them after so much is built up. But I remembered that, and when I did have these batteries I was making, I was using the gold Gans, and I had like your reactors. If you've got 2 sets of reactors, whatever gets stuck between the reactors, it's going to draw the fields. Putin has proven that. Anyhow. So I had basically the same setup. I had some on my deck, and there's a clock between myself and where I was working. And at one point, I had a few of these capacitors made, and they were just drawing. When I got rid of them and got them away from the house, well, things went back to normal with the clock. I think the gold itself, when you make the capacitor, everything's compressed and it becomes a reactor. It's got its own environment inside. I think it draws all the fields around. It's sucking the energy, or I don't know. These are the questions I'd like to have answered. I'm drawing.
It sounds very much like the beginnings of a Stargate.
I don't know.
So where you're able to travel from one place to another. It sounds to me like that.
Yeah.
I wouldn't interpret too much in it, because Cash also, I mean, he went into those questions about time traveling and stuff like that. I mean, think
about it, K-Van, if you have something that is a flow towards itself, if you make a flow toward away from something, okay, then you have a pull and a push. Isn't that what he's been talking about for positioning?
Okay, but if the time goes back, couldn't it be that the field somehow interact with the matter level on the electron and vibrational electronics, and somehow
if it's making a field, then it
reverses the process of electrons, like
it could be, yeah.
Well, some of this stuff is
I'm open-minded to anything, I mean, I'm not saying
but
time
you
traveling.
said, Bernard, that you also had some reactors in your shop running, right?
Well, I'm not that technically advanced in the physics part where the rest of you are conversing about, but I just know what I've tested with, and
the results of those tests.
Yeah, I've got a head for building things. not usually simple. I build everything in my head. That's my blueprint before I start. I mean, I've got the finished product in my head. I visualize it before I start. That's how I build homes. I was born that way, I guess.
Okay, well, maybe you can put a few things together for tomorrow and we can discuss some of these finer points. We need to wrap things up for today, I think. And
Sure, Rick. Well, I appreciate everything. So I just want to thank everybody for all their input. I learned steady.
Thank you, Bernard. Thank you so much.
Appreciate all your support, Bernard.
Thank you.
Good to know you're back there with us.
Oh yeah, I'm there. I'm pretty much here most of the time. I just kind of keep quiet at my end. I'm a little camera shy.
Okay. Well, you could do, if you want, you could do pictures and screen sharing, or share a video. You know, you don't have to share your face if you don't want to.
No, that's fine. I'll shave, and you can see my face. And I'll just show a few things. The paint stuff I'm making, a few capacitors. As far as the reactor, I don't know if I want to show that just yet.
Right.
It's basically set up for a Caroline core with coils on the outside as reactors. I've posted this on Facebook. You might be able to dig that picture.
Well, don't tempt us with it, and don't tell Mr. Kesh. He'll make you show it. So. Yeah,
no, I'm not ready. I'm not ready to show it yet. It does have like the wood power cells with it. I'm hoping it's a self-contained unit, but right now the preliminary test, it helped with the wires and what we've learned so far. So far, I've helped even with the connections on this. I pushed this aside for about a month and a half. I mean, I don't get finished with a project, it's obsolete. So I lose a little bit of interest in it. Now I've come back to it, and I'm going to apply some of what we've learned.
Right, exactly. I think that's the way it goes with a lot of these things. I've learned a lot in the last year or so that I'm going to apply to stuff from before, from previous reactors.
I've still got my reactors running because I need the fields for different reasons. My house is pretty much a big MAGRAV field. I've got some in different corners. I've got one in the basement. These have been running for, well, last Christmas we had a bunch going, and I had two going up here, and they were just, the rotations were changing at different speeds, and I got online when what was happening when you were firing up your reactors. Anyhow.
Yep.
I won't keep you any longer. I know everybody's got.
Let's wrap up here. It's getting on. So, okay. Thanks a lot, Bernard. And
been a pleasure. Call me Bernie. Bernie's cool.
Bernie? Okay.
Bernard's a little sophisticated, but that's my signing name.
Okay.
All right.
Thank you, Bernie. And thank you to Shandor for a long teaching day today. You did very well and presented lots of good concepts and hot tips there. All right, so that wraps it up for Tuesday, November 3rd, 2015, afternoon teaching of the Keshe Foundation Spaceship Institute. See you tomorrow.
Thanks a lot.